Hey everyone, I just wanted to do a fairly brief-ish overview of Houston and just kind of walk through the code a little bit to orient you guys and show you, based on seeing the GUI where the code for those pieces actually is and sort of how it all hooks up and works together. Um, so I guess a good way to start would be to do a quick demo and I'll point some things out. So I've got a terminal built into my editor here, and I'm in the SFU GCS virtual environment. So if you've done the installation instructions for Houston, this should be ready to go. So I'll just bring it up here and pop it onto this screen, and I'll just slide it into another space. Full screen, and now we can actually see it, so that's good. I'm just going to hit reset on my OBC so it'll start printing some stuff. So there we go. So the OBC is restarted and we're in the telemetry tab here. So this is basically just a raw readout of everything that the OBC is sending back, and right now when you start it up it prints various things like starting state machine, default start mode, things like that. So what we can do with the OBC is issue it various commands. So the results with the task details here, these are actually the result of sending a command that is just enabled by default. So I can do that again. I can just type in, get tasks and hit enter, and it'll send out that information. We have a bunch of commands, and I've done a video on how to add them. So we can do like state get, and we're in safe mode right now. We can do, I think I've hooked this up, state set to, which should be low power. Yep. It's going back to it. Get. Okay, so yeah, we're in state low power. So there's a little bug there where it's printing the wrong state. I'll have to look into that. Anyway, that's how you issue commands. So that's sort of the overview of the telemetry tab. So we have data coming in from the OBC. Next up, we have the schedule tab. So this is where we can create commands and give an expected response, and tell the system, tell Houston when to send the commands. And then we can take a look and see if the results came back okay. So we've got a couple commands in here by default, and we can delete ones we don't want and stuff like that. So let's do another command. Let's do state get. And the epoch is the time, the satellite mission time to actually run the command at. So right now, the way everything is set up is as soon as we click uplink down in the bottom right corner, the epoch gets zeroed out. So right now you can think of it as it will send this command to the OBC. In the case of this one, 5 seconds from now, or 5 seconds from when we click uplink. So let's just do 3 seconds. Expected response, state safe low, oops, we're in low power. And the timeout is from when you send it, the amount of time the OBC has to respond to you before we consider that command errored out. So either the data coming back from the OBC doesn't match what we expected, or something else happened, like the command didn't run at all and we just didn't get any response that matched up. So I'll give it a couple seconds. Things are basically instant right now. They come back pretty much instantly. But it's conceivable that we would need a timeout value in the future. especially if we're telling the OBC to do something in the future. We sort of want to have this command waiting around so that we're ready to validate it whenever that data comes back to us. The other thing we can do is check out the error behavior. So if we just issue a command that doesn't actually exist, and I'll give it a timeout of like 10 seconds. Once we don't see this, so the expected response is just some garbage, we're never going to get this response back. So this command is going to time out after 10 seconds from when we send it. So we'll send it, we'll add it to the schedule. And then we can click uplink, and we will send these commands to the OBC at these times in seconds from when we click uplink. So we will do that, and we'll just head over to the response tab, I guess. So right now they're all sort of yellow. And yeah, it's switching pretty quickly, but basically yellow is we haven't sent it yet, so that command is new. Blue is pending, so we have sent the command, but we're waiting for the response from the OBC. Green is validated, so we got the expected response back, and red means errored. So you can see that in the status. ACK means acknowledged, errored, and all that. So the state get command says we're in low power. That's true. The ACK command, that's just a simple test command where it'll just immediately respond back to you. So anyway, that's sort of the demo. And if we go over to the telemetry tab, we can see the commands we sent. So what did we do? We did a state get, and then an ACK, and then a garbage. So we have a state get, that's the response, an ACK, and then it received this garbage command, but it didn't reply with anything because it's not an actual command. Yeah, so anyway, that's the operation. That's what we can do right now is schedule and validate commands and review all the data. So we need to talk about code now. So Houston is developed on a framework called Kivy, which is for doing GUIs, graphical user interfaces. The first, like the top level file is the Houston.py. So the way this works, and it's actually easier to see in Houston.kv, is there's a hierarchy for everything. So in Kivy language, which is the .kv, objects are brought in with these brackets here, and those refer to a class in Python. So we have the top class, yeah, so we have a top class here, and the top instance in our layout. So the Python handles the control of and like sending data around and stuff like that, and the .kv file is your layout, sort of where stuff is on the screen, and also styling associated with it. So sizes, colors, whether it's aligned to the left or right, things like that. So you can see if we go under here, we have an instance of top, and then we have the logo, and that's sort of anchored to the top left. And if we just look, that's what we have. Then we go down and we have a box layout, and that'll just create a box that you can put stuff in. And so you can see under this box layout, we have things indented, and then those will end up under or in that box layout. So then we have our tabs. Yeah, so then we have our tabs, and we're just saying it's the full width, and yeah, So just a bit of styling associated with all this. So then within our tab panel, which sort of gives us these tabs, that like it's like a wrapper for the tabs, we need to actually create each tab. And each tab is created using one of a couple of classes. And we've got a separate class for each tab because each tab does pretty different stuff. So we have the UART tab, which is the telemetry tab. We have the, oops, went down to the bottom, the schedule tab, and the response tab. So each of these are a class in Python. So we've got those broken out into different Python files. So I'll just reorganize these a bit here. Schedule, UART, response. So at the top level, so as I said, each one of these is basically adding an object, so an instance of a class of type schedule tab. And then this is subclassing tabs panel item, which is just something we need to do for Kivy to say that this is a thing with a tab like control on it, and then this is all of the area underneath that tab. So in the schedule tab class, all of this stuff in here is laid out and controlled from the schedule tab class in this case. So we can go, I guess we'll probably look at the UART tab first. So inside a tab class, you've got various functions to do all kinds of stuff. And the UART tab is basically the most simple one, so we'll quickly look at that. And I'll try and point out a couple things, because there are essentially a few different concepts of how to link up Kivy, things on the screen, and like events like clicking on buttons and stuff like that. Linking that to your Python to actually move data around and process things and stuff like that. So let's look at this. So we have a function here called send button press in the UART tab. So that is connected to the send button. And I'll show you how that's done. So in Houston.kv, we have our UART tab. Again, we have a box layout just to organize things. And then if we go down, this is actually near the bottom, we have a button. Text in it is send, that's what it says. And then on press is root. The root object is the object with the greater, like wrapped with the greater than, less than signs. So calling root.anything underneath your tab means it calls that function in the UART tab class. So this is saying call the send button press method rather in the UART tab class. If we were to do this root dot something in schedule tab, it would call that function, method in the root class here, which is, bracketed by the greater than, less than signs, and then has this stuff indented underneath it. So that's how you talk from things on the screen to your the class that deals with controlling things. And so, okay, so we have our root.send button press. Let's go look at what that function actually does. So our method actually does. So we got our UART tab class, send button press. It prints stuff, okay. and it also prints the text field of self.uart entry. Okay, so what is that? So if we look up further, or well, near the top of the class, we have a member called uart entry, and that is an object property. So things, you'll see object property, numeric property, various properties, and a property is a member of a class that Kivy knows about, and they've defined a few different ones. So objects, strings, stuff like that. So it means Kivy knows about this, and you can see if we look in the KV file for uart entry, this maps, or we can map this to an ID. So this is a way of bringing the ID, so like the handle for this text input widget, bringing this handle up into our class so that we can access it from Python. So what we've done is we've said we have a text input, so just any Kivy widget. We give it an ID, so some unique identifier, kind of like a name. And then we're saying this ID of uart entry, I'm going to bring this up, and I'm going to say, so up in here, right under the, you can think of this as the class definition, or yeah, I guess kind of a class definition in Kivy. We're saying the uart entry property of this class here maps to the uart entry keyword or ID. So that lets us connect things back to Python when we say uart entry. So again, the same name we've been using for that member in the .kv file, which then maps down to the ID associated with a particular widget, is an object property. And so this means that the reference from uart entry eventually maps down to an object. And in that case, the object is the text entry box, text input box. And so using it in Python, we can map down to that box, and then we can say, I want the text field or attribute of that box, which happens to be whatever you have typed in there when this function runs, method runs. So that is how you map, or how you get things from your layout in your .kv file into a Python class so that you can deal with it. So it can be kind of confusing how you actually need to do this, and like where you need to use object property and stuff. But the good thing is there are a lot of examples throughout the code of how to do this. And you can see we do a similar thing. Well, we do the same thing fairly frequently. So we do it again in the uart class. RV is an object, and RV is the recycle view for the uart tab. And what a recycle view does is it will, it's a container that can basically hold, you can think of it as holding rows of data. And the way the data that a recycle view row, or that a recycle view handles comes into it is it's a list of dictionaries in Python. So we'll just look at the thing. So Populate, yeah. So we're saying RV, so recycle view. So this eventually it maps down to, in the KV file, an ID for our recycle view. So we are saying the data of this recycle view happens to be this dictionary. And the recycle view goes down and has a view class called UArtRow. And this describes how the data actually looks. And this is where we can pull out fields from the dictionary and print them on the screen. So we've got a recycle view that will repeatedly pump out UArtRow view classes. And we've set the data of the recycle view to, well, when we start up, to this value. So the value keyword, and then it's got init in it. So if we just jump over to the top, you can see it says init. So this is just the first value that we ever put in there. And then you can see insert ends. So this is what's called whenever we get new data from the satellite. We're saying to our data list, so it's a list of dictionaries, we're going to append, and then we just pull in the value that we've gotten from the satellite, and it's the key. This is confusing. The key is actually the word value, but this could be anything as long as it's consistent between our recycle view data, and then as long as that key appears in our view class for that recycle view. So here's UArtRow, as we were seeing before. And you can see here, we're giving it an attribute called value. And inside that view class, we have a box, and then we have a label. So just think of it as some text. And the text is root.value. So what we do is we're taking root, the attribute value from root, which would be UArtRow. And the way this works is the keys from the recycle view data dictionary list of dictionaries. The keys are how you grab different things from your data to print them out. So it might be a better example if I show you the response tab. Actually, I'll just do it in the KV file. So response row, yeah. So this is the recycle view class for the responses, where you could see we had the ID, the command name, and the state, so acknowledged or new or whatever. I'll quickly show you that just so you can see. So the ID, so this is a recycle view. It's a bunch of things repeated with different data. So we have an ID, a command, expected response, and a status. So in the code, we have various fields here. We don't actually show all of them, but we have the ID, we have the command string itself, and we're just initializing these here to a number, an empty string, number, and so on. And then in this, under this class, we have labels again, and like we did before, the text field of the label is the root. So the response row dot the field or the attribute is whatever this name is. And the way this works is the recycle view data dictionaries keys map to these. So the data coming into this RV has to have keys of command ID, command, timeout, expect, epoch, and so on. And that's how the data kind of comes in. So that is kind of confusing until you see it and you play around with it. So for example, you could, in the response tab file, take a look at where we update the RV. Yeah, here we go. Where we update the RV. So we're saying our response RV data, which is a list of dictionaries, appends, this is badly named, appends stuff, which you can see is a dictionary, which eventually comes out of our command. So that's kind of how you get data into a recycle view. And this video is getting long, so I think I'm going to stop, and then I'll do one more video about kind of architectural stuff and less about like Kivy itself.